Given the following equations in the form y equals a times b to the x, identify the initial value and the growth rate. So for the first one, we have y equals 5 times 2 to the x. So this gives us our total population, this gives us our initial value, this gives us our factor, and this gives us the shake number or the years. So for A, our initial value is 5. The growth rate is 2 minus 1, because remember you have your factor, you take away 1. Gives us 1, which is 100%. B, initial value is 500. Growth rate, your factor is 1.56. Take away 1, that gives you 0.56, which equals 56%. Given the following initial values and annual growth rates, write an exponential equation to describe the pattern of growth. We have an initial value of 154 and a growth rate of 127%. Two things that we need to write this is the initial value and the factor. We have a growth rate that's given to us. So let's take that, the growth rate, and change 127% to a decimal, 1.27, add 1 to it, and that gives us the factor. So y equals our initial amount, 154, times 2.27 to the x. Two siblings, Jack and Shelley, received $1 and $2 respectively on their birthdays this year. The grandfather told them he would double the previous year's gift for the next 5 birthdays. So we're doubling. This is similar to what we were looking at for our homework the other day. So Jack has 1. It's going to get doubled, so that will give him 2. The 2 gets doubled, and that gives us 4. 4 gets doubled, and that gives us 8. The 8 gets doubled, and that gives us 16. 16 gets doubled, and that gives us 32. Shelley starts off with 2. Hers gets doubled as well. So 2 double that gives her 4. 4 doubled gives her 8. 8 doubled gives her 16. 16 doubled gives her 32. And 32 doubled gives her 64. For each sibling, write an equation to model the growth in the birthday gift. So Jack, y equals, his initial amount is $1. The factor, what are we multiplying each of these by? So we were told to double them all, and so it looks like what we're doing is we're multiplying each of them by 2, so our factor is 2 to the x. For Shelley, she starts off with $2. Hers is also getting doubled. So the factor that we're multiplying each of these by is 2, and it's to the x. Identify the domain and range for each relation. So the domain for this particular problem, the domain is the x values, which are the years. And those are always positive values. The range for Jack, what he's getting out, those are the y values. That's the money in this case. And that's also positive. Shelley, her domain, same thing as Jack's. It's the x values. It's indicating the number of years, and those are always positive. We can't have negative years. And her range, Y values, that's the money, and the money is positive for her as well. Are the relations in Part B functions? For every x, do we have one y? Does it pass the vertical line test? And the answer is yes. Passes the vertical line test. When we draw these out, it gives us a curve. If the siblings continue to receive the money at the same rate, what will they receive in year 10? So let's use our equation. And for Jack, we have y equals 1 times 2. And we're looking at year 10, so we're going to replace that where the x is. So it's to the 10th power. So y equals $1,024. For Shelley, y equals 2 times 2 to the, again, year 10, so we're raising it to the 10th power. So y equals 2 times 2 to the 10th power, which gives us $2,048. So for your assignment, you have additional review activity 3, and that will be due on Tuesday.